students, so let's start this. So this is combination of cells. See, first of all, there are two combinations. Why should I use this color so much? I don't know. Parallel or series. So series or series combination. Series combination or parallel combination. What is the basic difference between series combination and parallel combination? I already teach you in the previous lecture. Why this pen is not working properly? Parallel combination. Parallel combination. Okay, so there are these two. Okay, just adjust this. Good evening, beta. There are these. What I am doing today? These. There are two types of combination: series combination, parallel combination. Okay, so I hope and believe you guys clear the basic difference between series combination and parallel combination. So please tell me, what is the basic difference between series combination and parallel combination? What I tell you already in the previous class, because most of the time we reverse the formulation. Reverse the formulation means we reverse the formula whenever there is a series combination, whenever there is a parallel combination. We generally do that. And this is reverse also. Like series combination of resistance is going to, the formula of series combination of resistance is going to be used as parallel combination of capacitance, and the formula of series combination of capacitance is going to be used the parallel combination of resistance. So there is one catch also. If you understand one, you can make an analogy, make a, you can say, relation, and remember or understand the second one. In series, current remains same. In parallel, voltage remains same. Exactly. If you understand in this way, that is the best way. In series, the current is going to be remain same. I is going to remain same. So the voltage is going to divide. V1 equals to IR1, V2 equals to IR2, V3 equals to IR3. So I take common. R equivalent is R1 plus R2 plus R3. In the same way, in parallel, current is going to be divided. I net, I total equals to I1 plus I2 plus I3, where I is V by R equivalent, which is V by R1, V by R2, V by R3. So we take common V, and 1 by R equivalent is 1 by R1, 1 by R2, 1 by R3, and so on and so on. Clear? So this is just a reflection, like combination of cells in series and parallel. Like they are connected with this in a series way with this bulb. Okay. So real life connect, it is used to find out how much current is flowing and how much voltage is dropped in various areas of the complicated circuit first. Really important. And then it adds in determining the direction of current in various circuit in loops. That is important too. Kirchhoff law can help you comprehend to find how energy moves via an electric circuit. See, that is going to be used in our household circuit. What is the meaning of household circuit? There is a very basic question in class 10th. Why the electric circuit of a household or of an household is going to be used or is going to be connected in parallel? Tell me why. You pass, you all, everyone passed out 10th with a good grace. If I'm not wrong, that's why you opt to go for JEE batch, JEE examination. So tell me why. Very basic. And please give me the detailed explanation on the basis of present knowledge of yours, not the previous one. Okay, my question is, I repeat my question. What my question is this. Why the electrical component or electrical circuit, CKT stands for circuits, is are connected in parallel. Connected in parallel. Are connected in parallel in household circuits. In household circuit. Tell me why. Very basic answer. Tell me, beta. Anyone? You tell me, this model. Beta, you look like a model. I don't know which particular model, but you look like a model. Believe me on this. You can try that field also. I'm not joking. Believe me, your features, your facial, what that particular jawline is really perfect. At least this age. See, Jyotsna is laughing, isn't it? No, you don't. I mean, you don't agree with my points in this at least. I mean, if he is good looking, so why not? No, you don't find him good looking. Don't lie at all at least. Sir, because voltage is important in household products. Wow. Thank you. Current is good. I can't see him. Oh, I'll paste a picture once. Not today because today is not look that much good. So I can one day, not today. Sir, because voltage is important in household product. Okay. Current is different for. So beta, why? Why voltage is important? Why we give so much importance to voltage? For me, current is important. So I can connect in series. Beta, I give you compliment to get the answer, not to get the thank you. Keep others running away, even if one falls. Yeah. Hari Mahesh give me the correct answer. Every device has different current requirements. So, parallel current ensure that. That is the correct answer also. In series, current remains same. In parallel, voltage remains. Okay, that is the answer. See, the answer is two, three answers are correct. The main basic answer is in our house, there is a 240, not 240, 220 voltage, which is going to be, if we're going to connect in, you can say, series, so the voltage is going to be divided. And voltage we need at least constant. We need to use current in the division. Why so? Because if current is not going to divide, so what happens? The current is going to be high or remain same. Suppose uh, current, I have current for 20 ampere. That is very high, but still suppose 20 ampere for each. So the heating effect of current, which we already discussed in the class 10th also, heating effect of current, heating effect of current in the previous class also, electrical energy, heating effect of current, which is electrical energy, H I square RT. Now with the time, I is already high, so square is going to be more high. And with other instrument, like suppose you are going to use refrigerator, the resistance is going to be high. And refrigerator, if I'm not wrong, running 24/7 in each household, right? So time is going to be high. So that is going to burn within hour or two. So that's why we divide current to minimize or to overcome this heating effect of current, or to save our instrument also. And the second thing, if they are connected in parallel, suppose this is your bulb. Okay, suppose this is your bulb, and suppose this resistance is of your fan. This one is resistance of your TV, RF, R, TV, or television, and that is bulb. So if any particular wire is going to be burned, suppose this is going to be burned, or that is going to be I is going to be 0, or that is going to be defective, like this particular bulb is defective. So other instrument working properly in that scenario also. So there are two cases for which we use parallel connection in household. First one is this. Okay, heating effect to prevent the instrument at the first case. If in any case any particular instrument is going to be defective, or it is going to be burn, or it is going to be any particular case, so the other is going to be perfectly fine. Okay, to save others, or you can say to save other instruments, as well as other instruments. This is instrument INF. I'm not going to write complete instruments working properly. Is this clear? I reconnect in parallel. Okay, and more complex problem you're going to face on the basis of this two things only. Like in series, the current is remaining same. So with the same concept, we're going to find the R equivalent of a cell. With the same concept, we're going to find the R equivalent when the cells are connected in parallel. And there is one question where in parallel or in series going to be connect. So their question, I mean their particular topic, I give you with the help of a question either in homework or either maybe in classes. Okay. So moving ahead, this is combination of cells. So again, there are two types of combination: series combination and parallel combination. So let's read out what it is written, even if it is not that much important, but let's go ahead. Often in real life, it is not feasible to make voltage source and batteries for very particular voltage value. Like in real life, what happens? We connect small cells to make a big battery. In the same case, small batteries to get the higher voltage. There are only certain types of batteries available on market. In case where a different voltage is necessary, for example, we have only, the cheap and easily available batteries are for 20 volts only. And for any particular instrument, I need 100 volt or 60 or 40. So how can I get the voltage in that particular higher order? So obviously I need to connect the cells or a battery in kind of combination. So there are two types of combination: simply series combination, parallel combination. Is this clear, everyone? So two or more voltage source are used in different combinations to produce the desired value of voltage and current. These batteries can be connected in two basic types of combination. These combinations make up the foundation for all other combinations. These two combinations are series combination, parallel combination. Why this is written over there? This is the foundation. The meaning of this particular word, where it is going, foundation of all other. Meaning of this, these are the basics ones, but you can use a parallel with series or a combination of two parallel with three series and n number of parallel with m number of what I'm saying, n number of series connection with m number of parallel connection. There is a perfectly example of this. Like why this is written over foundation. For simplistic, suppose there is one cell, there is another, then it is going to be positive, negative, positive, negative. So this is what it is, your series combination. But it can be go in this way also. Okay. So these are the simplistic one. What is the combination with these two? This is your positive, negative, positive, negative, positive, negative, positive, negative. Now this one is, suppose there are 1, 2, 3, 4. 4 are there also. Or suppose there are 3 only. And there are 2. So what is this? This is the combined combination of okay. So now when I added this, I get a bigger voltage. Okay. Just let me draw and then I'll explain. Positive, negative. So what I do here, there are 3 parallel connection. 1, 2, 3. In one, there are 4 series connection. 1, 2, 3, 1, 2, 3, 4, 5. In this, we have 4, 1, 2, 3, or if it is 4. In this, we have 2. Okay. So that is the meaning of saying n number of series connection with m number of parallel connection. And they are combined together. They are combined together. Is this clear? What I am doing, just connect 5 cells in one series, then 4 in one series, then 2 in series, and all together I connect in parallel. So there are mixed connections. In proper way, they are known as mixed ones. So this is mixed in what sense? Like parallel with series. But we can use in so many other types also. But this is the general in mixed also. Clear everyone? Okay. Parikshit, Hari, Yajira, Darshan and everyone. Oh, good. So that is why it is written over foundation. Means with the help of these two combination, even you can make different kind of permutation combination. And I hope and I believe you know what is a permutation and combination. Different methods to select different data. So this is your series combination. As I clearly mentioned. Okay, now anyone please tell me why it is positive and negative in reverse case. Why negative, negative not? Tell me. Very basic question. Why this E1 and E2? The E1, the negative terminal of E1 is always and always connected with the positive terminal of E2. Why so? The potential difference is VA minus VB and VB minus VC. Where is B? Okay. Yeah. Tell me why it is. My question is why positive terminal happened to my writing today. Why positive terminal of cell or battery? Cell or battery. Only then current will flow, right? Okay. Anyone else? Cell or battery. Connect to negative terminal. No, it's not. See, the current flow is going to be depend on the magnitude of voltage, not the direction. Whichsoever is the higher magnitude, the current is going in that particular direction. If I reverse this scenario, balance neutrality. What is this? Neutrality is what, beta? I hear this first time. I mean, I genuinely ask, what is neutrality? Okay, just tell me the proper English meaning of neutrality also. Because neutral in so many different scenarios going to change for each particular. What is neutral for me, it is not going to neutral for you. Right? Or is this something related to science? If it is science, neutrality means no positive or negative charge. Ah, okay, in that way. So, beta, if it is not going to be positive or negative charge, positive cancel with negative. So, why we are doing that? Then there is zero thing. Means we are doing hard work to get nothing. That's what I want to say. Why I'm so sarcastic today. The current will flow continuously. No, but I already tell the current is not going to. Current is depend on the. Okay, I'll give you this answer. Current is depend on the magnitude of voltage. Why we do so? Very basic, simple. Positive attract negative. Simple thing. If you try to, yeah, one thing this all voltage difference also. But if you try to connect with the positive terminal of a positive terminal, it cannot be connected so easily. It can be until unless the voltage difference is going to be very high. For example, if it is 10, then it have to be more than 50, 60, 70. Then it is connected. And why so? Because it is positive and it becomes negative voltage. So the normal, or you can say the summation is going to be 50. Clear? What it happens means the direction of polarity of this particular cell is going to be reversed. You can attach that, but then the net voltage is going to be 60 minus 10, which is 50. And as in that particular last slide paragraph, we add number of cells to get more voltage in general. Okay, we add also to get less number of voltage also, but normally it is not going to happen. In general, maximum number of times we add number of instrument or number of cells or number of batteries to get more voltage. Clear? So there are two basic things because of positive and negative attract. So they are easily connected. Okay, first point, and the second point is very common sense to get higher voltage. To get higher voltage. Okay, what is the meaning of saying? Suppose if this if in this way they are connected, so then net voltage instead of 50, then it is going to be 60 plus 10, which is 70. So that is why we are doing it. Clear? So we have E1, E2, EMF, E1, EMF, E2. So when we are going to connect that, after the connection, the EMF is going to be equivalent. In the same way, we have R1, R2, the resistance of a cell or a battery. So when we are going to connect that, we need to find the R equivalent also. Is this clear? Good. I don't know why I teach you so slow today. Okay, because the concept is easy. Already it is done in the previous class. So just the series combination. Keep in mind, in series current remains same. In parallel combination, voltage remains same. Okay. So in series combination, VAB, VA minus VB, E1 minus IR1, VBC, VB minus VC, E2 minus IR2. Thus, the potential difference between points A and C will be given by VA minus VC, which is VAB. VA minus VB minus VCB. This is VC. So it is going to be reverse of, instead of VBC, what I am going to write? VCB, which is VC minus VB. Okay. So then just putting the value, which is VA minus VC, E1 plus E2 minus IR1 plus R2, and to replace this combination of cells with a single equivalent cell of EMF value E equivalent. So E equivalent is E1 plus E2 simply, and R equivalent is R1 plus R2. So that is simple thing again. In okay, the same concept we are going to use. If why should I have made this? Okay, this one. This one is 1, this one is 2, this one is 3. Okay, and then yeah. Suppose EMF is what? Voltage, where current is going to be 0 or current is not flow. So understand in this way, this is V1, this is V2, this is V3, and they are connected in series, right? And at that particular cell we have R1, R2, R3. Clear? And then this is going to be connected. And then there is a question like find the net voltage or resistance in between A and B, points A and B. So as you know, in series combination, in series connection, voltage is going to be divided. So the net voltage is, or total voltage is, so net EMF, which is a voltage at 0 current, net EMF is nothing but V net. You can write E net equivalent V1 plus V2 plus V3. In the same way, net resistance. This is internal resistance. Whenever you can find small r, that is the meaning of internal resistance of a voltage, or you can say battery or cell. R net is R1 plus R2 plus R3. So even if you follow these standard formulation, even if you don't, the main thing is to understanding this. Okay, in series combination, the way we need to find, the way we understand till now, the same method is we going to follow. If you are not understanding this VA minus VC, VA minus VB, which is VC minus VB, it's not a big thing. The main thing is this. Clear everyone? Okay. Simply think in like the student Kayla maybe. In series, the current is remain same, voltage is going to divide. In parallel, current is going to divide, voltage remains same. This thing you need to understand that only. Okay, clear everyone? Everyone, is this clear everyone, beta? Okay, so series combination E equivalent is E1 plus E2 because we only connect 2 there, and R equivalent is R1 plus R2. This sign is need to be R1 plus R2. This can be extended to any number of cells. What is the meaning of any number of cells? Instead of 2 only, you can connect or add 3, 4, 5, 6 or n number. So this E equivalent is E1 plus E2 plus dot means n number. Okay, in the same way, R equivalent is R1 plus R2. Again, this is small typos. R2 dot till n number. Now the important case and important scenario even in series combination also. If the sign is going to be changed, in this case connected, the negative electrode of the battery are connected to the positive electrode of the another battery. In case we connect their similar electrodes. So again, when similar electrode, what is the meaning of this? Suppose this is your positive and this is negative. Now here you connect negative and positive. So they are connected in opposite way. What is the meaning of saying that they are connected in opposite way? This is, we'll write in the terminology of E1, E2. This is E1, E2. This is R1, R2. Okay. As you can see easily, this R1, this negative is connected to negative. So it can be, but only and only when the polarity is remaining high. For example, now E1 is going to be some 100 voltage and then it is going to be some 5 or something lesser, because in this case only they can do. In theoretical way it can be 10 or 5, it can be 2 or 3. Okay, in theoretical way, but in practical sense you can understand easily if in this way you can understand if there are two students or there are two, you can say, fighter who are going to be equal capabilities and skills, so they are going to fight in a longer run. They are not going to, you can say, defeat any other component easily. In the same way, if this instead of 5 I can put here 6 also, so what happen then? They are going to repel each other with equal amount of force. Like this is negative, this is negative, so they are not going to bound even. We can say that theoretically here net EMF or equivalent EMF is 1 because the polarity is remaining different, or the polarity is here in a negative sense, but this is just a theoretical aspect. Clear? I can do that also, but it is not practically acceptable. Clear? So if you connect in this way, I can write for figure, and this is your figure A. Okay. So this formula is for figure A. That is the written, like this paragraph is for figure A. In case, in this case, connected negative electrode to the battery, connected to the positive. Okay. In case we connected similar electrode, okay, together, then two EMFs will now point in opposite directions. In this case, the equivalent E equivalent is going to be, because we only connect 2, okay, and R equivalent is going to be R1 plus R2 plus dot dot dot. Why it is not negative? Because this is not dependent on the polarity. Your resistance is going to be added down, but the due to the change in polarity, due to this positive negative electrode, due to this positive negative plate or cell, the EMF is going to be reduced and it is going to be lesser, but the resistance is going to be added down. As simple as that. Clear? Clear now, everyone? Good. Now this is another combination. I am not going to spend much time on this because I already spent a lot on series. So in this time, the current flowing through the each cell is different, and they are denoted by I1, I2, while the total current flowing through the circuit is I, or denoted by I, and is the sum of both the two currents. So I equals to, okay, I total equals to I1 plus I2. As you can see, this is your I, and that is your I1, and that is your I2. In this way you can understand. And here we need to find E equivalent, R equivalent. So the same method we're going to follow, the same method we're going to use. V, which is VB minus VB1 minus VB2, which is E1 minus IR1, and E2 minus IR2. Now I need to find I, not V. I need to find I total. So I total, I equivalent is I1 plus I2. So from these formulas, I1 is V1, you can write, or simply V you can write. V, okay, this E1 minus V divided by R1. And similar way, I2 is E2 minus V divided by R2. Okay. So combining this here, this becomes E1 by R1 plus E2 by R2 minus V1 by R1 plus 1 by R2. See, resistance is going to be the same way, the way we're going to find it down, but R equivalent, okay, this E equivalent is going to be in this way. E equivalent by R equivalent, which is E1 by R1, E2 by R2, and R equivalent is going to be in this way. Okay, so rearranging this term, now this is your what? This is your total voltage. So it is going to be E equivalent, and that is going to be plus I R equivalent. So if you find this R equivalent, so automatically you get this. But if you find this E equivalent, so beta E equivalent becomes E1 R2 plus E2 R1 divided by R1 plus R2. And opening this, you can find this. Okay. Moreover, E equivalent is R equivalent divided by E1 by R1 plus E2 by R2. I know this is a little bit complex, but this is the way we can find it. Why this V remains same for both the case? Because that is the net voltage after the combination. Got it? Clear, everyone? So that is the scenario. Now this is going to be a little bit more complicated or complex. Instead of 2, I can join 3, 4, so and so. Got it? So then simply you need to do this. E equivalent equals to R equivalent E1 by R1 plus E2 by R2 plus E3 by R3. Got it? In this slide, in this page, I just added down 2. But what if instead of 2, I have 3, 4, 5, and maybe 6 also? Where I don't need to go that much away. Yeah. So what I'm writing here, just let me write it down in a proper way. Let me make it. Suppose this is your one. In this one, we have this one also. We have this one also. we have this, we have this, we have this one also, we have this one also, or I can draw in this way so many, this one also. Okay, now this is your 1, let's remove this, this is your 2, this is your 3, this is your 4, this is your 5, this is your 6. Now you can see that and say that everything is connected in parallel, right? Okay, let me choose another. This is the general. Okay, clear now? So now again, this is your A, in between terminal A and B. Even when I draw a cell, so there is automatically thing R1 is going to be, right? I don't need to draw this R1 or R3 separately. R1 automatically, E2 R2, E3 R3, 4 R4, 5. Okay, E5 R5, 1 2 3 4. How much I draw? 1 2 3 4 5 6. So then it is going to be 6, and that is going to be 5th. Okay, so R equivalent you can find easily in a initial stage. Clear? And then E equivalent using this formula. Instead of dot, you can put n number like 6, 5, 10, 11. Don't worry, more than 10 there is no going. They don't ask more than 10, 5 at least. But for 2 it is easy one. For 3 a little bit more complex. For 4 or 5 it is a little bit more. Okay, and it is not only the single case. Like in the combination combined thing, I was telling you in the beginning, then that is the case also. Clear? You look tense, beta. What happened? Jyotsna, why are you eating your nails? This is the bad habit. And what happened to you, sir, Parikshit? Your camera is blurred. You need to wipe out your camera once. Again it is blurred. Leave it. Okay. So if you have any question, query till now, you can ask me, because I think after then we have a question. Yeah, I know this. Okay. See, the simple concept is you need to stuck to your mind. You need to fix in your mind. In series, current remains same, voltage get divided. In parallel, voltage remains same, current get divided. Simple as that. The moment you understand this, I'm not going to say learn this ever, believe me. The moment you understand this, that is the easiest way to even derive the formula on the spot, even if you are not know the formula. Believe me, maximum formulas I don't remember. If I'm saying maximum means more than 90. I don't remember the formula, because if I'm going in this way, so then I can't remember the formulas. I don't have that much sharp memory. Okay, is this clear, everyone? And I suggest you also to not learn the physics, because the moment you start learning the physics, you start learning the even formulas also, then there is no better, because then you are doing in a reverse way, which is the wrong way. Like you initially learn the formula, then you are trying to solve the question. And the best way is the reverse. You understand the concept, you understand why it is happening, where we're going to use that, and how it is happening. Then apply that particular formulation on the numerical problem. The more you do, the more that particular formula is going to clear in your head. Because then after solving the numericals, you get to know in which way they ask the question. Because understanding the question is first task. But I feel with you after the COVID generation, I mean, what is the meaning of COVID generation? After the COVID batch, what I feel that maximum number of people, not people, that's correct, but maximum number of students, they are not understanding the question first. So how they use which particular formula, that is the hardest thing. Believe me on this. You are not the alone, and that particular thing is facing by maximum, or you can say 80-90% students right now. Because what happened, the moment we get particular numerical question, we just copy it and then we start googling it, and Google has everything. So that makes us, I'm not saying so dumb, but that makes us so lazy. We don't need to use pen and paper, and that is the worst thing being a student. The more you write, the more you understand. Simple as that. If I tell you my experience, my parents scold me to use that much stationery product in a month, at least 20 or more than 10 registers, rough registers, because I need to sell it out also, and I need to buy it also. Okay, but they were happy also, like because I spend their hard earning money in a good direction. So I hope and I believe you also start using pen and paper more and more, for two reasons that give you confidence to not use technology, to not use Google, to not dependent on the technology on the very first hand. And the second thing, you get habitual to write. The more you get habitual to write, the more it is easy for you to give the subjective paper. And you know also in boards you need to write a subjective paper. Even if you crack the JEE with very good grades or marks, and in your this particular board examination you don't get proper appropriate 60% or 50, 60% division, or maybe 70% is the minimum criteria, right? If I'm not wrong, to get into the admission of JEE, 70%, to get into the admission of good IITs, more than 70 or 80%. So then there is no use of that particular knowledge. Okay, so you need to prepare yourself in a both way, to write a paper in a subjective way, like how we can able, how we can get good grades in board examination, how we need to write in a proper sentences, like what is the method, and obviously you get to use, you get to know this thing when you write by your own self. Okay, even if you write the amount of questions we provide you, it is enough, sufficient. Clear, everyone? Okay, so try this. This is kind of integer type. Batteries of 10 volt and 5 volt are connected in series such that their EMFs are point in the same direction. The internal resistance of the battery are 2 ohm and 10 ohms respectively. Find the equivalent resistance for the system. Very easy. And if I'm saying so, it is. Okay, go ahead. And if anyone is not understanding the question, so let me know. You need to tell me the solution. E equivalent, or I can write net means total. And I don't think so on this, at this level, there is a much easier question than this. Okay, simple. Nice. Everyone? Anyone? Why not 5? My question, why not 5? E net. Why other guys take that much time? I need to know this thing. What happened, Harimesh? There is a two R net is 12. Okay, doing. Seriously? You require that much time for this? Beta 51, 51, 51. Okay, what you guys understand, please let me know, anyone. What is the meaning of this question? I guess everyone understand this, or I need to explain this one also. Sai, you tell me, beta, are you there? Your camera is not working if I'm not wrong. Yeah, it is. So why not you are turn on your camera if it is working? So it is mandatory thing. I can do that, but I don't want to do. See, if um, first of all, you need to understand this. Everyone here is good looking, and no one can see anyone else. The best thing. So you don't need to shy to just turn off your camera. Second thing, if there is any particular problem in your camera, then only you are allowed to turn off the camera thing. Because the moment I see your face, I understand what is going on in your head. Maybe not 100% correct, but 60-70% up to the mark. So tell me what particular thing you understand. I'm not going to ask Jyotsna every time. Believe me. Why so? Because she only turn on her camera, or Shrutika or Hari Mahesh or this Mario or this Sai Badri. Everyone is need to understand this thing. You need to turn on your camera. Got it? See, this is very simple, students. Why you take so much time? I need to understand this thing. See, question what it is states that battery of 10 volt and 5 volt are connected in series such that their EMFs point in the same direction. This single word clear it out everything. Clear? It is or not? Is this clear in your head also or not? Tell me this thing first. You tell me, beta. Sai. Is this clear what it is written in the question? What it is, saying that what that particular question describe? Are you typing or what? Okay, so tell me. Explain the question to me. Hmm. Explain me. Explain the question to each particular students also and me also. Go ahead, beta. Parmeshwar, Kritika, Darshan. Are you there or not? Okay, I'll explain you. I don't know where is she. But the simple thing is two cells, two batteries of these much volts, 10 volt and 5 volt, are connected in same direction. Meaning of saying that the positive terminal of first is connected with the negative. Simple. Okay. And the moment you understand this, then that is everything. Like sipping or sip of tea. Or sir, I have network issue. I keep leaving and joining. Kindly excuse. Yeah, why not, beta? Okay, so what I am doing here? This is 10 volt. This is 5 volt. This is 2 ohm, this is 10 ohm. This is the symbol of ohm. Okay, now simply in between A and B. So when this is the condition, E net, we know this, E1 plus E2, which is within fraction of second because the calculation is not that much tough, R net. Okay, I'll let me. So this particular question is needed to be done within 15 seconds or lesser than that. Now you tell me why you take that much time. Everyone, other than this Parikshit guy. Tell me, beta, Harimesh, you tell me. What is the catch you didn't get it? I mean, you did not get it in this question. Like the moment you write doing sarna, that's done. In between, in the meantime, you need to just let me. I mean, you need to give me the answer instead of saying that because this is not needed to done. I mean, doing sir after this. After what? Is V net and E net same, sir? Hmm. It depends on the polarity, beta. Maximum number of times it's same, but it depends on the polarity also. See, if it is they are connected in opposite sense, so obviously total voltage is going to be uh, V net is or E net is not same. Why so? Using this particular, like finding the net values and applying formula. Seriously, beta? Why you require a formula? Okay, I have a bad. I mean, I just keep getting this bad habit of laughing on the serious issues. I don't know from where I get it. This is the net voltage V. This is your equivalent and I plus R equivalent. So obviously, if E equivalent is lesser than the V, it may be larger than because the current is going to be flow from this also. Okay. So V is you can say E equivalent QU plus I EQU. But I R Q EQ. So now you can see that this is a little bit larger. Why so? Because some amount of voltage is developed to produce the current throughout the cells also, or some amount of voltage or EMF is going to be here. Okay. And voltage and EMF are two different scenarios. Why so? EMF is the voltage where current is zero, and voltage of any particular cells, combination of cells or a battery is that particular voltage or that particular potential difference or electric potential where current is going to be flow. Okay. So this time taking I don't feel good from maximum number of students. See, if in the class of 20 students, this question is not given by more than 10 students within a fraction of minute. I'm saying minute, not seconds. Means 15 seconds, 20 seconds. Then you need to do something really hard. See, the formula, you don't need to write formula because I want answer. And you also want answer in the JEE examination. I'm not saying write in the manner in which you need to write in a proper board formation, in a proper board or subjective answer. I don't say this. I say or I want net EMF or net resistance. Equivalent EMF, equivalent resistance. As simple as that. Clear everyone? So when I say this, just keep in your head, I need answer. When I say write in a proper way, I'm not going to say because you enroll yourself in a JEE batch. So there is no need to write in a proper way. What is the meaning of writing in a proper way if you don't get the correct answer or if you select the incorrect one? The whole hard work of your in solving that particular question is zero or not zero even negative. That is going to damage the other question also. So don't do this. You need to think in this way, like you need to solve within a minute. I don't know how many times I need to explain this beta. Believe me, there is so much high competition out there. If you are not preparing in this way since today, since that particular class, so believe me, you are lagging behind a lot. Okay, R equivalent is R1 plus R2, and it is going to be plus if it is more number. So then R1, R2 simply, and here we know E equivalent is E1 plus E2, simply 10 plus 5. The catch here is simple thing, same direction. If it is written opposite direction, then E net is going to be 10 minus 5, and it is going to be 5. Clear everyone? If it is written over here, opposite direction. Okay, then the net EMF is going to be lesser than the actual ones, or resistance is going to be added in the same way. Okay, clear everyone? So again I am saying, whenever I ask, since now this moment, answer in this particular class or in the coming class, just give me answer. I don't need your explanations like you are writing formula, you are writing the proper way. Don't write it beta here at least. You have proper enough time to write in other class or somewhere else, or even here we give you the time, or because in the 4th week of each particular month you get the paper or you get the weekly test on the basis of this board examination. There you write in a proper way, subjective. Write 2-3 pages for answer. Okay, I'll check personally, and I do that. Okay, so this is done. Try this one. 2 batteries with EMFs. This, this and this are connected in parallel across load resistor RL somewhere other than this R1, R2. The internal resistance of 2 batteries are this and this. The voltage across the load lines between. Okay, this particular question is coming in JEE. So this is related to your expertise and branch, and not branch, but where you need to fight. So first of all, read this question twice. Again, I am telling you there are 2 EMF. There are 2 cells of internal resistance, this and this. Okay, this is R1, this is R2, this is E1, this is E2. In this way we write in general books, not E capital, and this is RL in any particular circuit. Now, what they ask, the voltage across the load lies between this particular voltage. In between which particular voltage? Okay, you need to select the correct answer, as simple as that. Go ahead. Simply you need to find V equivalent. For that you require R equivalent. For that, okay, yeah. V equivalent you get from this E equivalent of EMF. Okay. So voltage is IR. From the formula of V equivalent, R equivalent, you get I in general, and then voltage across load resistor R. When you get I, so multiply with the R, which is 10, you get the answer. Solve this. For one more hint, I don't want to give you any hint, I don't know why, so, but I need to at the end. This is your RL, which is 10. This is suppose your one cell, which is 12 volt, and the resistance on this 1, right? This is your what beta? What it is? Cell 2, okay, and this is R2. So this is 12 volt, 1 ohm, 13 volt. Okay, let me write in the below. 13 volt, 2 ohm, 10 ohm. So I, or in this question, you need to require voltage here in between. So For that, what you require to do, you need to find this first, which is V equivalent or EMF equivalent. Okay. Obviously, V equivalent is going to be EMF equivalent. Why so here? Because there is no voltage in this. We need to find. So the moment you find E equivalent, okay, and R equivalent, find E equivalent, find. So you get I. Okay. And when you get I, sir, can I switch off my, yeah, you can. Okay. And when you get I, so just multiply V, one saying D, one saying B. Please say someone A or C also. Okay. I don't know why I'm being so sarcastic today. Okay. The correct answer is D. So the students who are doing that, they give the answer. Meanwhile, I'm explaining this. Okay. Somewhere 11.56, if I'm not wrong. Which is like, sir, what is load resistor? Here 10 omega. This 10. Or this is general. Oh, okay. Load resistor is better that particular resistance of any instrument which is not like there are two types of resistance in this circuit. Okay, good question. In each particular cell there is a resistance which is known as internal resistance of a cell. We uh, symbolize with this small r. Or load resistor is simply a particular instrument. Suppose you, okay, you connect these two cells to start your small fan in the, you can say, summers. Like we have a small fan nowadays which is going to be connected with your phone. If you haven't seen that, google that. Okay, there is a data cable, and with the data cable you can attach that particular small fan with the phone. So that particular fan is going to rotate. So obviously in that particular fan there is a resistance, right? Because there is a resistance in each particular instrument. So if I apply that particular instrument other than the cells, other than the battery, so that is known as your load resistance. Any particular thing. Instead of simply we say that resistance, but it can be any instrument like bulb, like small fan, like anything else also. Okay, that is the load resistance in general. Good. And the proper correct explanation is, this is the correct answer D. We find V equivalent first, which is 37 by 3. We find R equivalent, which is 2 by 3, 112. Okay. Okay, 10, 1, 2. Well, then I'm saying, yeah. Then voltage across load resistor or resistance, IR, this. Okay. So now, oh, nice. There is one more question. Okay, try this. In the gap time, I need to take a break. Okay, in the circuit here, E1, E2, E3 equal 2 volt and R1, R2 are 4 omega. Okay, let me explain to you guys and then I'll go on a break. This is easily written 2 volt. R1, R2, this is both the internal resistance are 4 omega. The current flowing between A and B through the battery E2. With this battery E2, the current is flowing in between A and B. You need to tell me the answer. Okay, you also guys take a break for 5 minutes and then start solving this. If you are not able to solve this, so it's okay. I explain it, but after a break. Is this clear? Okay, everyone. And then we're going to understand Kirchhoff's law. The meaning of this is 5 to 10 minutes. Hello. Am I audible? Hello. Am I audible, visible also? Yes, sir. Okay, so then give me the answer. I already took 5 minutes more at least. Not much, but 2-3 minutes. Tell me if any one particular student solved that question. So, what is the correct one? B. Beta, you ask for telling me. Don't ask. Tell me. Option B. Okay. Anyone else? Hmm. That confidence I need in my other students also. Like option B is the correct. Nothing else. What about others? Beta, where are you? Darshan, Shrutika, Shakti, this Shushita, Hari Mahesh. Hello. B, sir. How B, beta, Vishwanath? Tell me. Where are you? And what about you, Harimesh? You did not get the question at all, or you are solving? See, that particular question is very easy. It looks hard, but it is very easy. The moment I tell you, it seems like, yeah, it is very easy. Tell me, how you approach like other students? I'm asking, not Hari Mahesh only. How other students approach this question? I want to know. Like, what is the thought process? Share your views, beta, anyone, please. So I can understand like how you see that question and what is the basic thing I need to tell you. Because I teach you cells in parallel series, mixed also, not properly, but I let you know how you can solve if you get it, mixed one combination. And then there are two or three, this is the third question, very easy, very basic, one related to series, one related to parallel, and other also related to parallel. So tell me, okay, how you approach this question, like what is the problem you are not able to solve this question. Be the leader and tell me on behalf of every other. Tell me, beta, or Shrutika, or Shushita, you tell me, beta. You can use your microphone or this phone also, this earphone also. I don't know why you write that much. Where you need to write, you don't write. Where you don't need to write, you write a lot. I don't want to see your long messages here in chat box. You can speak to me also. Believe me, your voice is not that much bad. Everyone I'm saying. Because in writing you take time and then sir is the answer B. Ah, beta. It is maybe B. Sir, I got the answer. Okay, tell me what it is. And why it is also. Whosoever now telling me the answer, please tell me why it is instead of what it is. Because the correct answer is B. I'll tell you why. Okay. I mean, I'll let you know this is B. Now I am interested in understanding why it is B. Hmm. Give me the answer. Are you there, Yajira? You tell me, beta. 2a, sir, at top. E1 plus E2 equals to 4. Okay. Is equal. E1 plus E2. Beta, these are in parallel. So they are not connected in this way, first of all. And where you get 4i. Sir, I rejoined just now as I Got logout. Okay. See, that is very easy. Basics. Stick to the basic. I don't know how many times I need to say this. When the cells or voltage or EMF, anything is connected in parallel, right? So, between parallel, voltage remains same. From the very basic thing, we understand this. Voltage remains same. Voltage means EMF also. Because what is EMF? Voltage of a cell or a battery at initial stage or at I equals to 0. Means EMF is nothing but voltage of a cell or a battery when current is not start flowing. As simple as that. So voltage remains same or constant. Okay, voltage remains same or constant in parallel connection. This is the symbol of parallel. So you don't need to worry about this E net or something. So that is remain same. Whatever. E1, E2, E3, everywhere you get the same voltage, 2 volt. Now the other thing, what we are interested, R equivalent. So when two resistance are in parallel, so R equivalent is R1 into R2 divided by R1 plus R2. And how it is getting 4 if I'm. This is 4 into 4 and that is 4 plus 4. Okay. So then V equals to IR. What it is going to be? Answer. R1, R2, so that is 4 into 4 divided by 4 plus 4, which is 2. So, wait. Then there is a catch in this question. Wait. R1, R2 plus 2. I equals to 2 plus 2. Why it is written 2 plus 2 volts and R1, R2 into this thing. Okay. Okay. Got it. So this is you're going to be how much? 4 into 4 divided by 4, 2 ohm, right? And this, see, we need to find the current in between A or B. Okay, or this is the given current 2A, 2 ampere from A to B, or either 2 ampere from B to A. So if this is okay, let me write it down first and then I'll explain. I net is going to be 2 plus 2 divided by 2. Where this 2 plus 2 comes? This is because R equivalent is this and EMF equivalent is 2 plus 2. It is going to be. Why I joined directly in a series combination in this way? Because 4 divided by 2. So it is 2 ampere. The first thing is this. Why it is so? Because I need to find the I need to find the current in between A or B, right? In this question. So from here the current starts, and as you can see, positive connected with negative. So in between this point to this point, E net or voltage equivalent is in series only, which is 2 voltage plus 2 voltage, which is 4 voltage. And then R equivalent, because this is the net resistance we have in between A and B. So this is going to be how much? 2. So in this way you get I 2 plus 2 divided by 2, 2 ampere. Okay. This is clear everyone? And this is the proper written answer. The equivalent circuit can be drawn as since E1 and E3 are in parallel. So the current between A and B, I 2 plus 2 divided by 2. This is the way you can see that. This is just R equivalent, which is the parallel combination of 1 and 3. and the voltage remains same in between 1 and 3. So we just consider 1 or 2 because they are connected in opposite sense, or they are connected in same sense. So that is going to be 0 even in 3 automatically. But the resistance net is going to be play the role here. That is why we find R equivalent, and this even in E3 you can see that, as I told you, this is going to be in opposite sense, 2 voltage, 2 voltage. So this is not included in the net voltage. Got it, everyone? Okay, Hari Mahesh or other also. Okay, right, everyone. So that is the sense, and that is very easy, and that is why from A to B, because this is the direction from positive to negative, not the reverse, B to A. Clear, everyone, this thing? Everyone means everyone. Please write everyone if it is clear. So, okay. Good. And if you understand, I said this lines, I don't know how many times, again I am saying this. If you understand that particular concept, topic, question, solution, then only write yes sir, then only write the correct answer. Don't copy from others, because even if you're writing down, so when I asking na ki explain me why it is so, most of the students I see this in each particular class. I'm not talking to you like you. If you think I'm just talking to you, this is a general way. The moment one or two students give the answer, most of the students just copy that. Yes sir, we understand, that is B, that is B, that is B. Don't do that. If you are not understanding, ask me. If you are not understanding a 50%, 60% or anything, just ask me. Okay, that's why you join here. Ask me so many times, or obviously don't ask me that much time like I am getting irritated, like yeah, this is the very easy thing and you ask me this thing again and again. If it is difficult, so I already spend a lot of time on that. Okay, so this is just you can say history. What are Kirchhoff's law? This is the name, Gustav Robert Kirchhoff. They are two laws: Kirchhoff's voltage law, KVL, dependent on the law of conservation of energy. KCL, this is your first law. Okay, this is the first law. This is the second law. In short form, KVL. In short form, KCL. This is the law of conservation of charge. This is the law of conservation of energy. These are the basics law of conservation. So in boards, this is important for boards. They simply ask, write the statement of two laws of Kirchhoff. Write the what are the Kirchhoff's law? Write their statement and physical meaning. So whenever there is a physical meaning, write it. I mean this. They ask physical meaning. So what is the meaning they wanted to know from you? They means as a examiner or as a questioner, they wanted to know the real physics behind it. Like why you writing down this thing? What is the meaning? What is the sense in a physics terminology behind it? So this is the physics terminology behind it. KVL stands for law of conservation of energy. KCL, Kirchhoff's current law, which is the first law of Kirchhoff, or if you say Kirchhoff's first law, is based on the law of conservation of charge. As simple as that. Clear, everyone? Is this clear, everyone? And it is, believe me, important for boards. Okay, not for that much in JEE, but for boards at least. Clear na, everyone? Because after that there is a statement and theory, but nothing more than to explain as a physics terminology. So this is KCL, Kirchhoff's first law, or Kirchhoff's current law. So Kirchhoff's first law is similar to the law of conservation of charge, and it is in general the law of conservation of charge. As a result, a node or a junction is a point in a circuit that does not serve as a charge source or sink. Therefore, total K1 to N I total IK means the summation of every particular current towards a junction is going to be 0, where N denotes the total number of branches at the node with the current flowing toward or away from it. Means the net current, the summation of net current is going to be 0 for a branch wherever the current is coming or going away. As simple as that. Means in a simple way, you cannot create the charge, you cannot destroy the charge. As simple as that. Okay, this is the meaning. This is your node. This. Okay, nodes. So as you can see, I5 is going to be inward, I4 is going to be inward, or this I3 is going to be inward, where I2 is going to be outward, I1 is going to be outward. So the current going outward is taken as a positive sense. The current going inward to the node or a dot or a connection is taken as a negative sense. Simple as that. So current entering the node equal to the current leaving the node, I1 plus I2 equals to minus of I3 minus of I4 minus of I5 equals to 0. And in this way you can say that I1 plus I2 is nothing but sorry, I3 plus I4 plus I5. Okay. In the same sense, in electrostatics, the way we understand the electric field entering into the, you can say, surface or any particular symmetry is taken as a negative, and existing out is taken as a positive. Like if we have a positive charge, suppose this is your positive charge, so from positive charge electric field getting outward. Okay, so in the same sense, the current is going outward, taken as a positive. The current is coming inward, is taken as a negative. Nothing more than that. Clear, everyone? Okay. Clear now, it everyone. You can find it anywhere to. Just the main thing is. Okay, I'll give you this in a proper written way. Current entering to the branch or node, entering to the node or a branch is taken as positive. Positive or negative? Negative. And in a similar way, current going out and going outward to the node or branch is taken as positive. Clear, everyone? Okay. So let's quickly finish this thing. Now this is Kirchhoff's second law, is similar to the law of conservation of energy. As we know, energy can neither be created nor be destroyed, because the net change in the energy of a charge after it completes a closed route must be 0. What is the meaning? Understand in this way. Suppose you apply a potential difference here. What happens? The potential divided in these particular loops, so you can say PQ, QR, SR or PS. The sum of all potential, or you can say the sum of all potential difference on this particular resistance instrument is going to be 0 net. Because the moment you close the path, or the moment you start running in a closed path, the energy is going to be 0. Conservation of energy, as simple as that. Okay, so that is known as KVL, and really, really important. What different kind of questions also. So the sum of all voltage drops around the loop is equal to 0. VPQ plus VQR plus VRS plus VSP equals to 0. You can understand in so many ways, like energy is nothing but amount of work done to do something. So in running in a closed path, you cover the displacement 0 or net displacement is 0. So the work done is 0. When work done is 0, energy is 0. In general, in theoretical way, but it is not the practical sense. Okay. If you are running in a closed path, you lose energy. But in a broader way, that energy is going into the surroundings or in the environment. So the net energy remains same. That is the sense. Okay. If someone asks, sir, this is not the truth. Like, yes, it is not the truth. The moment you start running in a closed path or the moment you start running in a circular path, you lose your energy. Exactly. But that particular energy is stored in the system, in your surroundings. So the net energy is going to be balanced out. That is the sense. That is the meaning. Clear? So that is why law of conservation states that energy can neither be created nor be destroyed. But in broad sense, that is not equal also. Something you seems like sir saying something and then again revert back to like, no, this is not true, but this is true. So there are broader pictures always. In this particular picture, the net energy is going to be remain conserved. The energy you lost is going into the energy of environment. So that is how energy is remain constant. But in broader picture, that is not this. If it is true, so you can travel back into the time. Okay, this is some, I mean, in any particular class where the content is less, then I'll teach you that particular theory also, what I'm saying right now. But based on the energy conservation law, because VPQ is nothing, potential is what? Why I'm relating to this energy, work done and everything. Work done for particular charge. Work done to move a unit charge, right? Potential. So the work done is zero, potential is zero. As simple as that. In closed path. The main thing here is closed loop or around the loop. In closed loop or path. If it is not closed, so that particular law or concept is not going to fulfill. Then you have displacement not equals to 0, then you have work done not equals to 0, then you have this V net, which is net not equal to 0. Okay, is this clear now, everyone? Everything is related to each other thing. Nothing is going to be back and behind. So the total number of electrical components in the given loop is given by N VPQ plus VQR plus VRS plus VSP equals to 0. Instead of 4, if we have 5, so that is going to be 0. Instead of 5, if we have 6. So the general statement, the main thing is, in the closed loop, net voltage distributed among the instruments, among the different instruments is 0. Saying meaning of saying that you're going to understand in a questions format, questions language, but V1 plus V2 plus V3 plus V4 dot is 0. Or okay, let's V4 is 0, and more general, I equals to 1 to N VI. This is the general. You understand when you get the question more clear, but this is in proper written statement. The same thing I write it down in my way. You can do that also. In closed loop, the net voltage distributed among the different instrument is 0. That is what. Okay. Why it is 0? I explain you in a very detailed way. So sign convention, this is important. Based on this, maximum number of 80% of more than 80% of the students solve in a wrong way. So that is important. In a loop, a rise in potential difference or EMF from lower to higher is always seen as a positive. Now what it is mean? I need to explain so much sometimes. So suppose this is your positive and this is connected to negative. Then this is your connected to negative and then positive. And then this is the same. Just a simple example. Now it is your V1, it is your V2, it is your V3. If V3 is higher, so obviously the current is going in this way. But if V3 is very less or V1 is higher, so then current is going in this way. So that is the meaning of rise and fall. Okay, what is the meaning of rise and fall? You can read it here in a loop. I don't make a loop. You can make it if you want to. Suppose this is your loop, complete closed. Okay, so in a loop, rise in potential difference or EMF from lower to higher. From lower to higher means if it is 1, 2, 3. So as you can see that 3 minus 2, let me write something else because that is going to be, but 3 minus 2 is 1 and 1 and 1. Okay, this combination gives me 1, so let me write something else because then you are going to confuse even more. Suppose this is 4. So now you can see this combination gives you 2 voltage. 4 minus 2 is 2, right? And this is 1, which is connected in same way. So the net voltage is going to be 3. So in this way you are going to see from V1 to V3. The main meaning of saying that, explaining this, elaborating this, wherever the net voltage is positive, from positive to negative your current is going to be flow. And believe me, and you not needed to understand, you need to make the direction also, because you are not making the direction in this way, you are not clearing the direction in your head. So only with the help of positive negative sign you are going to confuse yourself and you are going to do the wrong numerical solution. Clear everyone? That is why it is necessary to understand which particular connection is we make and which particular path we follow. Even if you follow the reverse path, that is not the wrong thing. But then you get your answer in negative sense and automatically you get your correct answer. But the main thing, the moment you choose any particular path in a closed loop, you need to stuck to that path. Is this clear everyone? Okay, this is more clearly written in your books, but the main statement here is note, you need to choose a path and stuck to it in life also. You need to choose any particular path in between the closed loop, and then need to stuck with it, need to be with it. Check it not the correct. Why should I write it down? Suppose we are going to see, but I'll make it first and then I'll. Suppose this is one resistance. Here you connect this voltage. Okay, this is another resistance. Then we have this resistance. Let me go in a proper way. Just give me a minute. This is another resistance. Now you have this voltage which is positive and negative. And then you have another resistance. Then you have another resistance. Then you have another resistance. And now you have here some big voltage. So now it's your choice, first of all, to make a closed loop, first of all, right? Suppose A, B, C, D, this particular loop you choose. Okay, so now it's your choice. You want to go in this way or you want to go in this way. Clear? There are two opposite directions. There are two opposite paths. Either from CDAB or either from ADCB. But the moment you choose the particular path, you need to be with that. Simple as that. Because as you can see, these are connected in the same sense or same direction. So that is not the problem. But if they are connected in opposite direction, okay, I'll do that for you guys. If they are connected in opposite direction, okay, so then what happened, beta? In choosing the direction, you need to follow the positive and negative potential difference also. Like if you are choose this particular anti-clockwise path, so both the things is going to be negative. Why so? Because from positive to negative you are going, that is not the sign, because your voltage is going from negative to positive. Okay, so understand in this way, voltage is always and always taken positive. If you choose a particular path from negative to positive, or it is taken as a negative if you choose the path from positive to negative. Here in this particular path, anti-clockwise, we choose positive to negative. So whatever the voltage it is, suppose V1, so you need to take minus of V1. In the same sense, V2, it is also going from negative to positive, so it is also taken as a negative. Clear everyone? Because that is important. Turn on your camera, everyone, means everyone. Is this clear? Everyone. Crucial thing here. You're going to face the problem here in so many senses. Okay. This written thing you can find in any book, but the main thing is this. The moment you choose any particular path, you need to stuck with it. You need to continue your numerical problem with that. And this is the main thing. From positive, if you are going in the upper side or rising the potential, so you take the potential difference is positive. If you are going in this direction or in any particular direction where the direction follows the path from negative to, or you can say positive to negative side, then you need to choose your voltage in a negative sense. As simple as that. And it is written in here. In loop, as you can say, in loop, a rise in potential difference or EMF from lower to higher is always seen as a positive. First thing. Second thing, in loop, a reduction in potential difference or EMF from higher to lower is always seen as negative. Reduction means if you choose from positive to negative, that is going to be reduced. Reduction, negative. If the looping direction is same as the current flowing through the circuit, the voltage drop across the resistor is considered positive. Now this is the catch. Again, the third one, the important one. This particular, okay, this one. If I take the direction of my particular path in which the current is flowing, obviously if I choose this particular path, second, then from A to B, the potential difference here, VR1, is taken as a positive. But if I choose the particular path 1, then VR1 is also taken as a negative, because current is in the direction from A to B, not in the direction from B to A. Clear this one, everyone? Is this clear, everyone? Because that is how you need to solve. Believe me this. And that is very confusing when you doing in the first time. Okay. Okay, I repeat my words again. First of all, you need to choose any particular path in between the closed loop and you need to be with it. First thing, first scenario. Then if you take the path in which your potential difference or you are following the direction from positive to negative, from positive, then the potential is, the potential difference at that particular cell or battery is taken as a positive. If you if you take this negative direction, or you can say, I write this thing in a reverse way. Wait. Just give me a minute. Yeah. If you this from positive to negative side, so then it is going to be negative. And if it is negative to positive in this side, so then net potential is going to be positive. The second case, the current direction. If you're choosing the path in the direction of current, then the potential difference at particular instrument, at particular resistance or any other thing is taken as a positive. If it is not, so taken as a negative. This is your third particular path or third particular point. Is this clear, everyone? Or should I explain this again? Tell me. See, I know this is confusing. If you want to write it down, every particular single sentence other than the above one, so I can write it down, but if it is clear, so I don't need to. That's what I want to listen. See, the main thing is you need to choose any particular path in between the closed loop and then need to be with it. First thing, understood? Then the second thing, from positive terminal. My writing sucks today. From positive terminal to negative terminal. From positive terminal to negative terminal. I'm talking in terminal ways, not the terminal of airport, terminal of this cell. This is negative, this is positive. Voltage is taken as positive. Positive or negative? Negative. Because we are reversing the direction. Okay. And similarly, from negative terminal to positive terminal, the voltage taken as positive. That is what written in the sentences. See, in a closed loop, a rise in potential difference or EMF, lower to higher. As you can see, this is higher, this is lower, so we can take negative. This is lower, this is higher, so we can take positive. First case, first point is explained here. The second, in a loop, reduction in potential difference or EMF, higher to lower is always seen as negative. So this is your higher to lower. This is your second point and this is your first point. And the third point beta here is in the direction of current. In the direction of current. In the direction of current. Potential difference at any instrument, at any resistance I'm going to write, because that you understand easily, at any resistance is taken as positive. Clear? Means, okay, you can understand again here in this sense. Just a minute. Suppose this is your one battery. Okay, this is your resistance. And this is your again one resistance. Again one resistance. Again one resistance. This is another battery. Positive. And this is obviously negative. Okay. So now, suppose this is 2 volt, this is 20 volt. So automatically you know, if it is 2 volt, this is 20 volt, so the higher order magnitude, in this direction my current is going on. In this direction my net current. Right? Because it is higher in order. So if I choose my path in this way, in opposite sense. So better the current going in this direction, but I choose my path in opposite way. So what happened? We are 3 or 1, 2, 3, 4. 4. What potential difference at resistance 4 is taken as negative. Clear? This is your R1, this is your R2, this is your R3, this is your R4. So the potential difference here, or I can write it down, VR4 is taken as negative. As simple as that. Why so? Because I choose my path in anti-clockwise direction and the current is going in clockwise direction. No. Wait. The current direction and the path follow direction is same here. What are you guys doing, beta? This is the direction. As you can see, the current is going in this reverse direction and I choose my path in this direction. Okay, the current in this particular loop is flowing anti-clockwise. This is the direction of current and this is the direction I choose. Clear, everyone? So it's your choice or it's your wish which particular direction you need to choose. Clear, everyone? The 3 points what what in this particular slide written over above, this is the meaning. The main thing is choosing the path. The second thing, seeing the potential, like from which particular rise or reduction we are going on. And more important, sir, can you show the points? Okay, yeah, why not? You can note it down after the class also. Because I think I need to give you this. Okay, beta. We are running out of time in explaining this simple sentences. So you can write it down after the class. You get everything in a PDF form. This is limitations of Kirchhoff's law. There are various limitations. So let's focus on the important one. Kirchhoff's law has one fundamental law. It implies that there is no changing magnetic field throughout the loops region, which might induce a change in magnetic flux and the creation of EMF in the circuit. This might result in a calculation mistake for high frequency AC circuit. What is written over there, I have explained in a single sentence. As we know, when the magnetic flux or when the magnetic field is changed, this is magnetic effect of current. Like when your current starts moving, so your magnetic field generates. In the same way, when magnetic field starts moving, the alternating current generates. EMI, electromagnetic induction process. Okay, you're going to understand in coming classes or in coming chapters. So in any particular loop, we cannot use Kirchhoff's law where magnetic field is going to be changed. Why so? Because then there is a miscalculation or mistake we are going to see in calculating the AC, which is alternating current. Clear, everyone? In more clear words, I can't express. Okay, because I need to teach you this 6 MCQs, which is more important. You can slow down my pace in recording 0.75 and then you understand what I'm saying in a speed manner. Again, I am saying whenever magnetic field is changed, so alternating current generates. But we cannot follow this change in magnetic flux in the KVL, which is Kirchhoff's second law. Okay, I don't think more explanation requires this. Kirchhoff's law also ignored the impact of electric field generated by the other circuit components. Okay, KCL, Kirchhoff's current law, works the premises that current only travels through the conductor and wires, while parasitic capacitance can no longer be overlooked in high frequency circuit because conductor or wires serving as a transmission line in certain circumstances, electricity may start flowing in an open circuit also. Okay, this is the a little bit more complex subtopic or concept. There is a current passes through without any connection also. Okay, we're going to understand how so, where so, why so. So in that particular scenario, KCL is not going to flow. But for small gap, the current is going to be passed from this also without anything. You can say anything, but this is not anything. With the help of air particle or this high charge flow the current without touching. Like one real life example I can give you. If you just go near about the 11,000 volt electric wire, that particular electric wire sucks you, or you can say attracts you within a fraction of second. Like most of the accident you can see, or you can YouTube, you can Google it. whenever any particular person or passenger try to travel on the roof of the electric current trains or railway system, then most of the time they are going to die. Why? So even if they are not touching the wire, the moment they just go near to the wire, that current is so high, that charge is so high, that particular current is attracts within a second, and then they burn within a second. I mean, that is very drastic way to die, but that is it is. Okay, so you can YouTube it, you can Google it, and then in the next class I am going to explain this, where it is happening, I mean why it is happening. So this is your question. In the circuit given in the figure is not given, I'll provide you. Current is different branches and the value of one resistor are shown. The potential at B with respect to A is. Okay, I give you the figure and then we talk about why don't the figure is provided in the circuit. Just give me a minute, beta. So this is your figure. Okay. So using this figure, tell me the answer. Potential at point B with respect to A. I think you know where A, where B. With respect to A, the potential at B. Try this, solve that quickly. Solve this, or should I need to solve for you guys? Okay, I do that because we are running out of time. See, a circuit diagram, we need to find VB minus VA, because to get the potential in between this, from the circuit shown below, current through 2 ohm resistor will be 1 ampere. Where is 2 ohm? This one, because 2 ohm is resistor or 2 volt is. So I equals to V by R. I equals to V by R. V is 2, R is 2. That is 1. Okay. VD minus VB. Where this? Wait. I need to give you proper diagram. Then you are able to understand. A, B, C, D. I don't know this conversion of PPT to PDF. How many times I need to see the problem regarding it. Okay. This is the way. So as you can see, this is 1 volt, or this is R. So what is VD minus VB? This is D and this is V. So obviously VD minus VB is 2 volt. Here we have only 2 voltage, and VC minus VA. Now beta, VC. This is your VC and VA. So how you can find VC minus VA is 1 volt, because here the current is passing 1. So obviously 1 current is passing here also. So 1 ampere current and resistance is 1. So then you can say 1 volt. 2 minus 1, 1 simply. And then VD minus VC minus VB minus VA, which is 2 minus 1, which is 1 volt. So VB minus VA, VD minus VC is 1 volt. I mean, just using the concept of KVL, you can go ahead and check it. Using KVL. The direction you need to follow, the each particular resistance, the potential difference you need to follow, and you need to check the sign of all this also. This is negative, this is positive. So this entire process. Okay. Is this clear, everyone? You need to use KVL, as simple as that. Do with yourself, obviously you get the answer. But the correct answer is A. Okay, this one is find the value of I from the circuit in the figure. below. That is very easy. Just follow the direction of the given arrow. I mean, you need to tell me. Hint here is using KCL, Kirchhoff's first law, find I. And how you can find the summation? I don't know how. 1, 2, and I 0.3. 0.3. See, it is going inward negative, outward positive, negative, and then negative, positive. So 0.5, 0.4, 0.9, 6, 7, 13, and 2, 15. If I'm not wrong. 6. Okay, it is going in. So 6 and 7, 13 to 15, 15, 5, which is 10, and 10 minus 4, which is 6. So how you can say 3 ampere? 0.6 ampere might be the answer. Let me check also. Yeah, 0.6. That is very easy. Okay, apply instead of, okay, it is written Kirchhoff's first law. I thought KVL. Apply Kirchhoff's first law at point P in the supplied circuit. As a result, we know, I mean, the current going inward is taken as a negative, current going outward is taken as a positive. So 0.2 ampere, 0.5, 0.6 minus this, and then that is it. Okay. This is plus, not equals. Because if I'm not wrong, 0.2 and 0.4, 0.2 is going in. So that is taken as a negative 0.6. I mean, use this as simple as that. The sign convention may be the wrong. But you need to show. This is one. That's it. You know, the current going inward is taken as negative, and current going away is taken as positive. Okay. So this is the summary. Now you have 10-15 minutes, not properly, but 10-15 minutes. Go into the test link and see the test. And if you want to know anything by my side in the test, so I can teach you guys. And the summary of this particular question, what I am saying, the summary of this particular class is combination of cells we done, cells in series, cells in parallel, and importantly Kirchhoff's law.